All right, thank you for attending today. We're reviewing residential reports with Gil here. This webinar will be recorded and the recording is sent out to all attendees. We've been including it in the Code Adoption Toolkit, and there's a drop down there for all of our recordings. If there are any issues with audio, my name is Erica DeLello. I'm project manager for NORESCO. And this series is sponsored by the Colorado Energy Office, and Shums Coda Associates created the training materials. So Gil and I have been working with Colorado Energy Office for a couple years now, and we've provided trainings like this, just like this one. Here we've got about 6 more in this Wednesday webinar series. So if you are interested in attending any others, feel free to email me and I'll send you that registration link. And then in addition to that, we also offer tailored group trainings or technical assistance for code adoption for jurisdictions that are looking to maybe come up to the 2018 or even the 2021. And then we've put together a code adoption toolkit, like I mentioned before, and it has a bunch of resources on it. I've added a few things for 2021 as well. And you can go ahead and access this through the Colorado Energy Office's website. And if you have any questions or suggestions for added content, just feel free to reach out to me. And then throughout the webinar, we do want to encourage questions. So if you do have a question, please write in the Q&A and we can let our presenter know at the end of the presentation. And the chat window, I know Gil likes to ask questions to the audience too throughout. So feel free to write in that to respond to any questions that he has for you guys. And then there is the ability to raise your hand and ask a question directly. So with that, today's presenter is Gil Rossmiller, and he's been in the construction industry for over 40 years. He's been a chief building official. He's served on many committees. He's the code guy. So he's he's got the answers to your questions, hopefully. So Gil, I'll go ahead and stop sharing my screen if you want to take it here.
All right, that sounds good. Well, welcome everybody, and we're gonna do our level best here to review some reports and all kinds of wonderful stuff that deals with energy. As Erica said, we can answer questions anytime. Pretty laid back here today. I'm going to be looking at several different reports and having some fun. So whatever it is you want to ask, please do. I've got, let's see, I just need to open up the chat here. Cool. Yeah, type in questions, do the chat. And Erica's absolutely correct. I will be asking questions like I'm going to do right now. So we're looking at, in theory, a res check. So last week I started with ComCheck. This week I'll start with res check. And so I want you to look at that for just a second. And I want to ask if anything stands out. That's what I did. So I'm going to assume all the square footages are right, just for fun, right? We'll assume that's right. And yeah, this is also a question that makes you, that I know you're listening, right? You're not like answering emails or something, right? Or eating. Gosh, it's lunchtime for you guys, yeah? So what stands out? Is anything that stands out here that might be kind of unique or you might want to question? Is there anything that is like, Chuck, yeah, we got, it looks like we're doing certainly slab on grade. Yeah, and what they're saying here, we'll look at that, is that the insulation, first of all, it's unheated. So they're not doing like radiant heat or anything in there. And they're saying that the insulation depth is going to be 2 feet. So 2 feet can be right down, it could be right, but it has to come to the top of the slab. And they're actually saying in this particular climate zone that they're going to be doing R5. Okay, let's see, James, what do you got? R19 continuous insulation on wall one, but no cavity. And Chuck is like, R5? What's that? Well, understand that what this is, what ResCheck is a trade-off, okay? And so this is, we're able to not put as much insulation or U value for windows or, that kind of thing in one space, as long as we can make it up in another, right? Oh, and Ryan's like manipulated the UA to match exactly. See this, you guys are looking at it. This is good, right? It's good stuff. So we'll look at everything that here. And Cornelia's like, what? 0.27 windows? There's a lady. She knows what she's talking about. Good job. So let's take a look. These are all, yeah, what is the zone? Well, let's see. I didn't blank out the, I guess I did. Some of these I didn't blank out the, keep the, right, innocent from, nameless or whatever they call it. So climate zone 5. This was down there in Canyon City, and this is 2018. So a lot of you come up with it, right? So Kristen's like ceiling value, not enough for climate 7. Well, so that's the beauty of it. And so great comments. These are really, really good. We'll look at all of that stuff, okay? So the first thing we have to understand, yeah, Tim is like compliance better than code. We'll start at the very top. Tim, that's absolutely correct. So it says 0% better than code. This is why it's a good one, because it's got a lot of good stuff on it. And it's just small, it's not that big. You will pass as long as your UA is the same or less than what we call the reference house. Okay, so in this particular case, this is what we look at. It says maximum UA, so that would be if I built a prescriptive house, okay, right off the tables, my UA would be 401. What they did is in their design and how I'm going to build this building, they came up with 401, pass. It just can't be more than 401. It could be exactly the same. I know, isn't this is great? This is a good one. This is a good one. So then we start to look at the assemblies and kind of like what's going on here, okay? Well, let's look at the ceiling. Now, we had a couple of comments that said, hey, this will never make it in climate zone 7. No, the beauty of it is it might work if they had really good walls or really good windows or had floors that were exposed and had really good insulation in there. So what you want to have to kind of get in the mindset of is what we're doing is making sure that what they're showing on their ResCheck is what they're showing on their plans, not necessarily does it meet the R value prescriptive table, because it may not, which is why they're using the ResCheck so they can trade the stuff off, which is perfectly legal, right? Yeah, Ryan says, interesting, ceiling isn't 2 layers, cavity continuous, 90 degrees to cavity. So when you look at, very good, Ryan, very good. So when you look at it, there are those that would say that this is, let's say this is a regular, right, flat ceiling or scissor truss. So let's say this is a flat ceiling, just like typical truss, right? Maybe a 412 roof, something 512 roof. And we've got 2x4 bottom cords, very typical in a truss, yes? There are some that will say, okay, what is between the bottom cords is cavity, and everything that's above the bottom cord, right, that 2x4, is going to be considered continuous. There's a big debate between jurisdictions, energy geeks, as to which is correct, okay? The idea behind this, to be truly continuous, per the definition, it is over all framing members. Continuous sheathing, like on a wall, right? On the outside, like the sheathing on the outside wall, it's continuous over all the studs, all the framing, everything. There are no breaks, okay? Then there are those that say, in a typical truss, the only, quote, thermal break isn't really the entire bottom cord itself. It's simply the webs that happen to be right poking through the insulation. So whether or not you will allow the split, as in Ryan was talking about, and cavity would be the 3.5 inches, or if it was a 2x6 cord, the 5.5 inches of bottom cord insulation has an R value, and they put the rest as continuous. That's really up to you. The strict letter of the law, this is correct. Cavity only. If you were to ask anybody in the Department of Energy or anybody at PNNL, they're going to say it's going to be cavity. In reality, I've seen it both ways. And many times in this particular case, the fact that it's exactly the same, right? That would have made a difference. Yeah, if they'd have had continuous insulation over here and it was the same, if they'd have put it all cavity, it would have failed. So I was kind of glad to see that it was all here, okay? So all we're doing is making sure it's about 2,000 square feet attic space, okay? Then we get this wall wood frame, and you're exactly right here on this one. We've got caddy of an R19, and then we've got this piece here, okay? We've got R1. And so would that depend on if the structure is a truss or if it's an old and open structure? Yeah, so I think that's an excellent point, Ryan. So what Ryan's talking about is if he's got an older structure, if it's like a hand-cut roof, then you've just got ceiling joists and rafters. You might have collar ties in there. You might have a few braces that come down and really old style framing, like 2x4 top cords, way back. They'll have a kicker that comes down from mid-span of that 2x4, which is basically a 2x4 rafter, and it'll kick it down to one of the interior walls to keep it from the roof from sagging, give it some strength. Again, personally, I don't get bent out of shape if I see two numbers in the ceiling area, okay? If they're passing by more than this, I might say, we're cutting it kind of close here. But again, it's up to you. But Cornelia, you got your hand? Would you want to say something? I don't know. Can I make it talk, or I don't know.
Yeah, I can go ahead and allow her to talk. Cornelia, you just need to unmute yourself.
I just wrote some questions in the Q&A.
Oh, great. Thanks, Cornelia. Yeah, I got it. Yeah. So, yeah, good. So we'll talk about that. I have a tendency to start getting, I'll try to keep on track. Yeah. So, and Bill, you're right. Yes. So Bill says, in my experience, that R1 is cheating. Absolutely correct. Because the software already accounts for the rest of the assembly. And Cornelia, that's exactly correct. We don't put anything here. So what the software is doing within itself, it is already taking into account any other R values that might be part of that wall assembly, the siding, the wood sheathing itself, that the studs are 16 inches on center, any sheetrock that might add to the R value, any air films, when you start calculating the overall U factor for an assembly, there are what we call air films on the outside and the inside that have a very small R value that you can use. That is all defaulted in the software. The only thing the software doesn't know is what insulation are you putting in the assembly, and is it cavity between the structural members, or is it continuous, okay? So Ryan's put in, could R1 be insulated siding? Yes, it's possible. However, because of the way insulated siding was done, you must then subtract so much. Let's see what that is. I want to say 0.17, something like that, because what's happening with that in vinyl siding and insulated siding like that is the product for R value is calculated using is calculated using the vinyl siding and the insulation that's in it, and that's not allowed. That's actually two materials to get an R value. So you have to subtract a certain amount, and maybe somebody can remind me where that is, but there is a place that says that. And somebody type in where that is. I'm not finding it. I know it's somewhere. I see my brain saying it. And it was a big issue in the code development process. Yeah, see, here's the insulating siding, but there was somewhere that said that. Perhaps somebody could look that up and put that in so I don't waste time here. Somebody look that up and get me that section, would you? You subtract something and I can't remember where it's at right off the top of my head. So anyway, let's get to this wood wall. So anyway, this is that R1. So you would look at the plans, and what I would expect to see is an R1 continuous insulation over the entire outside or inside. It could be inside the wall. 9 times out of 10, they're putting that in because they think they should, and they shouldn't. Okay, shouldn't at all. Let's see, Stanley, how is the R value for wall wood frame established? Well, Stanley, well, you know what's it's going to come from ASHRAE. That's where they're going to get it from. But what I can do is show you a very quick example. Let's see, wall R value picture. All right, so this is how it's done. Okay, very quickly. Okay, so you can add R values. What you can't do is add U values. Okay. Yeah, so we'll get to that too, Ryan. Yes. So what you do is there's air films that we're talking about. So this is a regular old 2x4 wall. And what you have is you've got a table or a row that has the R value at the insulation, and you have an R value of what it would be at the stud. Okay. And so the air film on the outside would be continuous, and these numbers, this is an R value, would come from the ASHRAE Book of Fundamentals. That's where it comes from. Then we've got plywood siding, and it has an R value, and it's continuous over everything, yes. Then I've got some 1/2-inch wood sheathing, and that's certainly continuous over everything, yeah, because it's sheathing. Then we've got a 1-inch. I said, let's put some 1-inch insulation board on there, and it's continuous over all the sheathing. So that's going to be continuous. It's over the whole assembly. Well, then we get to the insulation or the wood stud itself. Yeah. Well, I'm going to say I've got R13 batt in this wall. That's what it's going to be at the insulation, but that's not what it's going to be at the stud, is it? No, the stud's only going to have an R value of about 4.55 because there's no R13 insulation over the stud. That's the quote thermal break, right? Then we get to gypsum board and the interior air film, and then we add it up. So we got a little over an R19 at the insulation, a little over kind of almost an R11 there at the stud. So now we get to figure out, okay, how much of the wall is wood, right? And how much is insulation? So this is what they call the framing factor, okay? I just picked 20%, okay? Doesn't make it right, doesn't make it wrong. It'll be some 20, 25%, it'll be in there somewhere. So that's the area that's wood. And so now we just kind of do math, right? So 80% of our wall is at R19.27. 20% of my wall is at R10.82. And we do the math. And so we have this overall R value of this 17.57. And R values and U values are reciprocal of each other. So 1 divided by R value gives me my U value, or 1 divided by the U value gives me my R value. So we do the math. Right, did I do my slide right? 1 divided by 17.57 equals 0.057. So that's how you get the U value. Okay? And if they're using other in here, if I see other over here and said wall other, they're going to have to give you that calculation. It won't show a picture like that, but they'll give you a calculation showing this is how we came up with our U value for our assembly. So that's how it's done, Stanley. Hopefully that wasn't too much for everybody. Okay, good. So yeah, the other thing that we need to watch out for that Ryan had brought up was that R19, and that was the other thing I advised on this particular res check, was that what kind of a wall are we getting R19 in? Because you're right, R19 bats were never made to fit in 5.5 inches. They're 6.5, maybe 7 inches thick, depending on the manufacturer. Okay, so we don't allow that thing to get crushed in there anymore. They actually have to reduce it. In the code, we kind of lost that too. That's not in the code anymore. So you're not going to be able to put an R19 bat in a 2x6 wall unless it's been manufactured at 5.5 inches. I personally do not know anything that is manufactured as an R19 and is 5.5 inches. You can get an R21, right? You can get an R21 and put in there that's manufactured at, right, 5.5 inches. So that's the other thing, questions is like, well, what are you doing? How are you getting that? And because we don't allow that anymore. Not even the crush factor that used to be able to say you have to reduce it by an R value, but we got that. That doesn't exist anymore. And nobody's come up with the way you have to just subtract for the final siding yet. All right. So the U factors here for doors, that's just going to be a label, the NFRC label there on the assemblies themselves. Same with windows. We went over that in quite detail with commercial windows. Most of these are going to have stickers on them for what's happening, right? And then we get down to this next one. Yeah, somebody picked up, well, what is this? I got a 2x6 wall that's continuous R19. Where's that happening? Great question. You'd have to look at the plans and see, is that really true? Do we actually have that? Yeah, I doubt it. I suspect that 19 number should have been over here with the cavity. That would be my guess. But you have to look at the plans to decide, right? You would have to see. Slab on grade. Now this again is linear footage, okay? Not an area, it's linear footage to do that. So just verify this is possibly a walkout basement. And then we've got, looks like a 9-foot basement wall. And they're doing an R11 drape because it doesn't say it's furred. So we would just make sure that that's the case on the plans. And if this is the way they built it, if the plan showed me all of these assemblies that exact way, this would pass. This would pass. It's just that the plans didn't show it that way. And so they will be redoing this. Okay. All right. So I don't want to spend that much time on this, but that's okay. So this one has, I won't spend a lot of time here. This is the same kind of thing we looked at the commercial piece. It's generic. It's not project specific. So there are going to be plenty of things here that may not apply to a particular project. Okay. Okay. So you can see here that 0.0% were addressed directly in the ResCheck software. So yeah. So clearly the designer didn't check boxes, add any comments, which is nice if they do. But again, you just go through and it talks about all the things. So the white ones here are number one. If you do nothing else, would you please at least make sure this happens? Then the blue or whatever that color is the next. And then, I don't know, is that green? Goes down to number 3. So anything that's got this white, it's like, that's a number 1. If we do nothing else for plan review and inspections, that's the thing to do. So we do the same thing here in ResCheck that we did in ComCheck as far as these inspection checklist pieces. You as a jurisdiction need to decide, am I going to tell these guys they have to fill this out? Or are you okay with that? I got jurisdictions that do that. Okay, that's completely up to you. And so now, what is this? Oh, okay. So this would be what we get in theory for a performance house, okay? And so here we've got this really cool certificate here. It's a projected report. So what we're looking at here is something that you would get during plan review, okay? This is something that still has to be tested, and this is important to get during plan review to see if it's anywhere near possibly passing based on performance. This number here, this HERS index score, we don't care what it is. Yes, and we will get to that very thing, Ryan. We will show you what an ERI report looks like, and it looks somewhat like this. How's that? Yeah, I will show you what that is, but it's not on this one because this is performance, okay? So every one of them will start out like this HERS index score, we don't care what it is. This 62 for a HERS score, home energy rating system, means nothing to us code officials. Nothing whatsoever in this day and age. What matters is this stuff. If I got it big enough for you, let me know if it's not big enough. Okay, so what we're looking at, yeah, this report is based on a proposed design, does not confirm field enforcement compliance of the design elements. So clearly, this is just what they propose to do. And these guys, this particular rater, this company will actually do inspections to verify that what they need to verify for the performance piece, which will be blower doors and insulation installation and air barriers and all kinds of wonderful stuff, okay? What we're here is right here, used to determine compliance because it's the mechanical heating, cooling, domestic water heating, and the little bit of energy it takes for mechanical ventilation. Okay, that's what we're looking for in performance. So what we're looking at here is, here's the what we're calling the reference house, which is a code house. Here's the way they actually built it, and the costs for those items. If this number here, 2,711, is less than 3,080, we pass. Okay, this is the performance path. Okay, all the different requirements are going down through here. So this is one of the things that we do worst case. And so they're saying it can't be any leakier than 3 ACH 50, because this will be in, I think this was a climate zone 5. Okay, house. We don't care how much it passes by. Again, this could pass by 0% and would pass code. Be the same things as a res check. Okay. So again, this is basically the thermal envelope. Okay. So they might actually get a little bit better because most houses are testing less than 3 ACH 50, so that'll help them. That'll help them out. Okay, keep it up. Okay, so Godfrey or Jeffrey says, why does the HERS rating matter and why is it there? Well, that's a great question. And for some reason, my questions aren't just popping up on the bottom. I have to page down, so I apologize. So what this is this is all about marketing. That's what this is. This is a marketing piece, okay? This is when they explain to the homeowner rather than getting into all the gobbledygook that we get into, okay, as far as, you know, code geeky stuff, okay? This is just saying, hey, if I were to build a house, what we call this reference house, okay, this is a 2006 house essentially. And how much better is it, okay? How much have I saved based on a house that was built years and years ago? So this is basically, and the lower the score, right? This is the whole, a 0 on a HERS rating is a net 0 home, okay? So what we're looking at here is just a marketing piece. That's really all it is. You know, the lower the score, the more energy efficient your house is. And what did your neighbor get? Yeah, well, my house was a 58 and your house was a lousy 62. Whatever. Okay. Again, it's all based on marketing. There are, you know, some scores that, you know, deal with different programs that are out there, like Energy Star House, right? You'd have to get a certain score, right? So this is just a feel-good number for marketing. That's really all it is. Good question, though, Jeffrey. Good question. So what we're looking at here, then, is not so much, you know, this is a wonderful, nice, cool little certificate. However, what we're making sure is that these values here, 49 attic, 21 walls, right, 30 flame floors, looks like it's either a walkout that didn't provide insulation or they didn't have any slab on grade. Okay, so we'd have to look at the plans to verify that. ACH, 3 ACH 50, and then is this where our window values were at? So all we're doing now is looking at the report that spits out this little label, if you want to see the label, is what's happening in the house and is it correct based on the construction plans you're given. So this is a healthy house, over 11,000 square feet. Yeah, it's a healthy house, okay? And then it starts to say, okay, what kind of systems do we have? Well, this one had 3 HVAC systems, okay? And this is just what they're speculating is the worst that the leakage to outside could be, okay? So it's all worst case when they're looking at guessing, you know, from what I call a from plans rating, okay? Talks about what the CFM is going to be, okay? This one actually is putting in an ERV, or excuse me, an HRV. They're saying it's 70% efficient. It is. It's a pretty nice one, okay? And the amount of air that's coming in kind of gives us, you know, general idea of what the building is. And then we start to get down into the details of what has actually been put into the software to calculate that energy savings that we looked at in the very first couple of pages there, okay? What we're doing now is, hey, is it a crawl space? Did they put in, right, R19 drape all the way around the outside? They're saying, hey, the slab is uninsulated, below grade. You're not having any kind of an R value there. And we just start going through all the different pieces that they said. So here, the rim joist is going to be an R21. They give you the surface area of it. Personally, I don't like calculate the area of a rim joist personally. I just make sure, right? Yeah, right. 11,000 square feet be a fun blower door test. Yeah, no kidding, huh? Yeah, well, they'll be doing it. I can guarantee it. Yeah, so exterior walls, right? It says R21. You know, they kind of get into the surface here if you want. So you just literally work your way through all the different stuff, the glazing, the glass. That's it, right? And we're just verifying what's there. That's it. Yeah, it's easy. It's a piece of cake. Well, it takes some time. I mean, it's not something that happens in 2 seconds. Yeah, and here it's saying the attic and any vaults is going to be an R49. Okay. So literally it just goes on page after page after page. It's going to have blower door test, right? And here's that ventilation coming into it, right? You can verify if you want to get right down to the nitty gritty. Was the HRV 90 watts? Is that what it is? Did they give you the cut sheets on it? Verifying that what they're putting in lighting is 100% LED. That's what they're saying. Everything's LED. And then we get into generation that they're not having here. We'll get into that a little bit. But here is the conditioning equipment. And you think that makes a difference in the calculation? Yeah. What's the efficiency of the different units that they had? Does it match what the plan said? So here it is, right? The size of the equipment, does that match our manual J? right? Is everything kind of copacetic? Because this all, you think, yeah, this all makes a difference in what the heating and cooling costs are. It's based on the efficiency of the equipment. You bet. Anyway, it goes on, distribution equipment. I think you get the idea. We're just trying to make sure we got apples to apples. Here's the second furnace, and there'll be a furnace 3 here. Hers is more than marketing. Bill saying it's required by Energy Star and DOE Zero Energy Home. Yep, that's what I was saying. You got to do it. Boulder has a code requirement based on the ERI, which is very similar to hers, and we will look at that. Yes, we will look at that, absolutely. But you're right. Yeah, it's marketing, but you're right. If I'm going to do a net zero energy home for Department of Energy, it's a requirement, and so it is with Energy Star. And what are those? Those are both marketing, both of them. Yeah, just saying, hey, no, it's a great marketing piece. We're not only an Energy Star home, but we are a DOE zero energy, net zero. What is it? Zero energy something home. I can't remember what all the acronyms stand for. Oh, ready. It's a zero energy ready home. So you've got a thermal envelope and things that will actually provide net zero if you add solar and things of that nature. Okay. So you're actually right, Bill. But it's all marketing. It's not a code requirement. In some jurisdictions it is, like Boulder, right? Most places it's not. Okay, so we're going to move in. So here's that ERI. So here's an ERI. Okay. Well, it first tells you what the HERS score is. I don't care. Yeah, look at, Boulder requires a net zero energy ready home for any over 5,000 square feet. Well, this one would qualify. I'll tell you that. Yeah, they'd be putting a lot of stuff in there to get to that net zero ready home. Absolutely. So again, we don't care what the HERS score is, because this is my ERI, and that is what you're going to see. Right? Projected energy rating index report. Okay. Again, this will now have, what is it? Well, this is taken up a lot. Okay. Then the code, we need to know, are you using, is it with photovoltaic stuff or is it without? And then this one clearly is without, right? Because it's the same score, right? If it was with PV, that score would certainly be lower. Okay. And then we start to look here, right? And what does it have to be? Well, if we looked at it, in order to be able to qualify for an ERI based on my 2018 code, it would need to have an ER score of at least 61. This has a 61, we pass. Okay. Now, I don't have the thermal envelope report along with this one, but it would be the same thing. So what we just looked at for the performance path of all the different, walls and U values and all of that would be in the same report. I think this one also has, no, just the ERI. I think when Robbie gave this to me, now the other thing that's interesting, you don't see very often, and I think you just went through the 2000, let me see. And every once in a while, you'll see, I'm sorry, I'm going to make you dizzy so we can get through it. Here's something else you don't see very often, but works, okay? This UA is the same thing as ResCheck. It's just that the software can spit out the same thing, okay? Sometimes, it doesn't happen very often, but sometimes you might get a performance report in the very beginning that says, yeah, we're going to do performance. And then the report you get at the end isn't a performance report. It's a UA compliance report, or they're using this software to show UA and plan review and in final. Either way works. The problem is that the ones that started out as performance, there was some issue somewhere. And when they finally did a final rating, it didn't pencil out, didn't pass. It may pass UA, but it didn't pass performance. Okay, so you can do it lots of different ways. I just wanted to point that out because every once in a while you see this from this Ecotrope software, which seems to be the software that a lot of guys are using these days. Okay, so how about, I know this is your, oh, let's see, we want to get to here. What did I want to do first? What's this? Ventilation. Okay. All right. So what I wanted to get to. Oh yeah, I wanted to go here. All right. So this. So you remember this piece that we just looked at? Remember this one? This is the one we were using, right? R21 walls, right? And all the wonderful fancy equipment and all of that stuff, okay? This is the, yeah, this is the Manual J. This is the heat gain and heat loss for that same exact house, same one, okay? So now we're kind of talking apples to apples. And so I'm going to hear it say, wait, ResCheck UA isn't performance. We've seen that confusion a lot. You're right. However, Ryan, if, so I'm saying if, and it's happened, someone during plan review, okay, sounds good, Chuck. So if they say during plan review, they say, we're doing performance. We're going to do performance and we get that from plans rating and yep, all looks good. As long as they build it this way, we're good. Well, then they build the whole house and the guy comes in and he does the rating and he does the compliance and it doesn't pass performance. Oops. Now what do you do? Yeah, what didn't it pass? I don't know. Maybe they didn't do the insulation right. Maybe the windows they put in got wrong. I mean, I don't know, right? But they can still pass based on UA. And that's okay too. Just because they started with performance and made a mistake here and there doesn't mean they can't use another pass to show compliance. I know, is that confusing or is that like a no-no? I don't think so. I think we're okay. Because it's all a choice. Heck, they could do performance and then come back and say, well, actually, we built a prescriptive house. We're just going to do it that way. No, then they just have to show that they did. Yeah. So this is the Manual J for that same exact house. Does anybody see anything right off that hits them in the face? Just look at the descriptions. That's all you got to do. Look at the descriptions and see if there's anything you see that jumps out at you. Well, first of all, it says that all the walls were R16, not R21, right? R16. They've got below grade here, some R19. That was at least close, but 7,000 square feet of the walls were wrong, right? I've got some really nice windows here, 0.29. Too bad the performance report said they were putting in 0.32. Yeah, oh, wind speed 15. So let's talk about that, Stanley. That's fine. Yeah, no, it's good. See, Chuck, you're all over it. R16, good job. Wind speed 15, what's that all about? Stanley asked. All right, so what this is all about is that these are default wind speeds, okay? This is something that ASHRAE and ACCA and people a whole lot smarter than me figured out that this is my quote, average wind speed during the winter and during the summer. Right? These are defaults within the system. Any of the softwares, and if you pick up your manual J book, it will do that. And I actually just made a code change that will be in the 21 code. Gosh, I should probably get that. It should be in there, the new table. I got rid of this in that table because it was just confusing the daylights out of everybody. And that table should look a whole lot better. You know, I should go in and look at the 21 IRC and so they got it printed right. Yeah, anyway. So yeah, the big thing here, when you're looking at this, number one, you know, heating design temperatures, right? 3 and 91, is that right for your jurisdiction? Construction descriptions, right? Are they even close to what the construction plans say? Or in our case, did we have we had that performance report we just looked at? They all need to coordinate. They all need to say the same. Is the dry bulb temperature correct? So Anthony, dry bulb, depending on the jurisdiction, Stapleton, right? When you go into the software, you can find, depending on the weather data, there might be 5 or 6 Denvers, okay? All going off different times that the weather was taken. So 2009, 2015, right? Was it DIA? Was it Stapleton? Okay. The idea here is to pick whatever the jurisdiction is adopted, and if they've adopted something different, something that's not within the software, it's not default in the software, you can change this. The designer can change it to whatever it is that you said. So instead of 3, it's supposed to be -1, as an example. These will just turn bold. These numbers will turn bold, and if they're bold, that means they've just changed something that's a default in the software. And in your case, if it's supposed to be a -1 and it says -1 and it's bold, then it's okay, because it's supposed to be -1. Indoor temperatures, right? I don't get bent out of shape if they're a degree or 2 here, but technically that should be 70 degrees and 75 for indoor, okay? A 1 degree here and there is not going to affect the equipment. Room to room flows maybe a little bit, but it's not going to affect the equipment in any way, shape, or form, okay? Okay, so that's really very quick on that. You can tell a lot from just this page here. It's called the project summary page, and this is Wrightsoft, by the way. I'm sure you've seen a lot of Wrightsofts. And here where we're, you know, kind of checking on things like ducts, okay? If we see a load here, that means the ducts are outside. If we don't see a load here, that means they're all inside the thermal envelope. We're going to look at central vent here. That's our ventilation piece. This one decided they were putting in a humidifier, and if they're putting one in, more power to them. What we don't want to have them do, though, is here. I missed this. Oh, bad. Very bad. Yeah. See, Gil's not infallible. I don't want them to design for more than 30% if they're putting in a humidifier for winter. 35 is, I'm not going to lose a lot of sleep. I'll let myself go on the fact that I didn't catch this. 50% for cooling and 30% here. We just don't want to have condensation where it shows up. I probably will just make a note the next time guy submits and say, hey, let's not do more than 30%. That's actually in Manual J. As a recommendation, it's not a code, okay? But I think it's a good recommendation. Then we end up with our equipment loads, and here they actually used, instead of average, a lot of times I'm showing you guys average infiltration, they're actually using blower door because they're going to do a blower door test, and they've done enough tests on these places where they figure, hey, we're in good shape, and that's the leakage rate we're going to have, and that then relates to the infiltration number here. You know, how much CFM is being brought in for that. Yeah, I mean, this is just one of the systems in that 11,000 square foot house, and it's the size of most houses for 4,800 square feet. Yeah, so this would be just like one place. Okay, run out of time. I need to move on. So here's one with that ventilation. Okay, so just another zone in that same house. Okay, but this is where they put the HRV. Yeah. And so we're putting the central vent here, and it's heat recovery and what the load is, because right now it's bringing in 100% outside air that's unconditioned, right? And it's recovering 75% of that heat and cool. And so the system itself doesn't have to work as hard to reheat or cool, right? Over here, cool that air. So it's really nice. So this is good. Again, they did the blower door and duct loss. So here's another great example of a particular part in this same house that had duct loss. So all we're going to do is say, oh, all right, well, let's just verify that the ducts are outside the thermal envelope. And if they are, cool. Yeah, they should keep it in their load, you bet. But if all the ducts are inside, then this doesn't belong here. Yeah. So you're seeing a big loss here, a big gain here. Heat loss, heat gain. And then we get to this little thing here, this little worksheet piece. This comes with it. The nice thing about this is you can look down here because it'll give you the entire house. Okay, that's what this is, the entire house. This is all gobbledygook. This is just stuff that we looked at the construction. This is construction components. This is just what they call these things, right? They just give it labels. But the nice thing here is it tells you what the gains are. So they're saying that this house has got 12 people, and believe me, that is quite possible. That's right. It's quite correct. We actually get into appliances. And for a house this size, 6,400 is not bad. Usually we see something a lot. Stanley says, what's the bottom line? Past failing when data man, yes, in particular, what percentage range is acceptable? You've got an excellent question. There is no percentage and there is no bottom line. How's that? It's about an honest answer as I can get you. Best thing to do is that we got to make sure the dry bulb and wet bulb or dry bulb temperatures for winter and summer are in the correct spot. You're in the same place in the country that you're supposed to be. And all of those descriptions that we went through are correct. Okay. Areas are correct, U values are correct, R values are correct. Okay, that's the best you're going to be able to do. I mean, that's a whole day's conversation. And there's lots of things. There are lots of things that will make these things fail. Okay. Bottom line, if any of these are wrong more than a couple of degrees, we're done. The rest of it's gobbledygook. If the construction components piece that we looked at here, this one, instantly wrong, because the plans showed R21 and so did the performance report, said R21. So, well, instantly, I'm not spending any more time on this one, it's wrong. Okay. So yeah, just looking for key components without going down the rabbit hole. Well, those are some key components right there, Stanley. Design parameters, wall construction, the building thermal envelope itself. Okay, that's the best one we're going to be able to do without spending a whole lot of time. Yeah, those are the big ticket items. Is it anywhere close in the square footages? Right. Yeah. Okay. Good. Glad that helped. So how about Manual J? or excuse me, manual D, do we have a duct layout that actually gives us what the fittings are? Yeah, what's a 2K? Does it give you a picture? This is just a picture of the software. This works. What does that look like right there? What does that look like right there? Could you relate to what that is? Somebody tell me what that is. You got 3 minutes. What does that look like right there? Any guesses? Well, how about that? This one usually is really long. And this comes off the top. Yeah, it's a takeoff, top takeoff. That's exactly right. Yeah, when was the last time you saw a takeoff like that? It is huge compared to the duct. Well, that's what this designer used to make it work. Because I'm telling you, the friction loss or the total equivalent length for something like this is a whole lot shorter than something like this. That's why I think it's important. Whenever I call, I say you have to have the fitting numbers and you have to have pictures of them. Otherwise, I can't make head nor tails out of it. All right. Questions? Okay, we're getting to the end here. Well, I did the R value picture and I did it with ventilation. Okay. What else? Okay, so here's something to point out. So there really is no difference between a 2KO, a 2K1, and 2K3. It's a great example. It's all the same fitting, that we saw, that 2K. What this means is that how many are downstream? Okay, so how many takeoffs are downstream of this one here? Well, none, because I did a trunk reduction. How many are downstream of this one? This one is not good, but it's pointing to this one right here. How many are downstream? 1, 2, 3. Oh, isn't this fun? So I'm looking at all of these fittings here. There's another one that snuck in there. So I've got these 3 fittings. So I don't know anything more about them. So I can't see what's going on up here. Which one's the longest? Yeah, good. That's okay, Tim. We're good. Yeah. I'll tell you right now, which one's the longest? This one right here. First one. Because what's happening to the air? It's going right down to here and it's seeing this trunk reduction and it's now repressurizing and the air comes back. So this one's the shortest, then the next shortest, then the next, and then that one. This one here, look. That's why trunk reductions here are so important. If they're showing a trunk reduction, it makes a big, big deal. Outside air, combustion air for the water heater. What that is in ventilation piece. And so when you're looking at the ventilation piece of it, it's looking at 3 different things when it's calculating the central vent. Okay, a good question, Cornelia. It's looking at how much unconditioned air are you bringing in. Okay, it's looking at the volume of the home. It's looking at the combustion air, because this is something that happens in the background. It's something that the designer will input into it. You just don't see it. There's no report for it. Okay. So it calculates the largest CFM from combustion air requirements, the number of people, or 0.35 air changes per hour based on the volume of the home. Okay. Yeah. It looks at all 3 of those. And whatever the biggest one is, that's what it uses. So that's the explanation on that. Okay, so what else? Because we got a couple of seconds here. Anybody got anything else they'd like to chime in on? Gosh, I don't know. What else? What do you want to look at? Anything you see on here that I didn't explain that you want to learn about? I know it was so quick. An hour is so quick.
Thanks, Gil. That was a great presentation. Yeah, if anyone has any additional questions, feel free. Gil and I will stay online for another minute. And hopefully we'll see you next week for residential inspections. And otherwise, thank you everyone for attending. All right, we've got a lot of thanks.
Oh yeah. Good stuff. You're very, very welcome. It's good stuff.